Now for the final objective of this section, we have compositions of a trigonometric function and its inverse. Now we have two forms. We can have compositions of the form f composed with f inverse, such as sine of sine inverse of x, and that'll be equal to x for all x between -1 and 1, because again the ratios are restricted. The x is restricted from -1 to 1. We can also have cosine of cosine inverse. That'll be equal to x for x between -1 and 1 inclusive, because again the restrictions on x. Then we can also have tangent of tangent inverse of x. That'll be equal to x, and that's actually for all real numbers, minus infinity to infinity. Things get more complicated when we have, well, and recall, those are actually the restrictions on tangent. There aren't any for that ratio. They can be as large as you want them to be. In fact, you can even have approaching a vertical tangent value. All right, so then if you have these compositions of the form f inverse composed with f, that would be arc sine of sine of x. That's equal to x, but we're restricted between -pi/2 and pi/2 inclusive, because now this x value is no longer a ratio. This x value is an angle. So we have the angle restriction. All right, arc cosine of x equals x between 0 and pi. Same logic there. Arc tangent of x equals x whenever you're between -pi/2 and pi/2, not including the axes there. Now this difference again occurs due to the restricted domain of the inverse functions. All right. Now if you have something in these forms right here, the f inverse composed with f, the result that you get, it's equal to x only in those regions, but instead of being x, it's going to be a reference angle of x that's actually in that domain. All right, so if your output was 5pi/2, it would end up being pi/2, for instance. That would be a reference angle then. Or, I say a reference, that's just a coterminal, but it could be something like it's just in another quadrant. We have to actually reflect it back into the first, second, or fourth quadrant, depending on the function. So let's evaluate the following. We have arc sine of pi/3. Now as long as our angle, let's just point out, these two undo each other, they are inverses, as long as you're in the right domain, right? So as long as if it's a ratio we have on the inside, as long as it's between -1 and 1 for sine and cosine, or an angle between -pi/2 and pi/2, or between 0 and pi, depending on the function, if it's in that region, then the answer is just going to be that function value, right? That input. So pi/3, because pi/3 is between -pi/2 and pi/2, arc sine of pi/3 is just pi/3. Again, that is in our domain, perfectly valid. This next one, however, arc sine of 2pi/3, is not going to be in our domain, right? So that's 2pi/3 is in quadrant 2, and for arc sine, we're restricted to 1 and 4. So we just need to find a reference angle then for this. We need a reference angle. So that would be the reflection of that angle into the first quadrant would be pi/3. And again, these are angles, so that's why I'm talking about reference angles and all that. All right. Now, cosine inverse of cosine of 2pi/3. That, once again, is in the second quadrant. Well, arc cosine, that's fine. So actually, the result of this is just 2pi/3. Next part of this, number 6, is arc cosine of -pi/3. So -pi/3 would be in the fourth quadrant. That is not in the right quadrant for this. So that means this is the reference angle, the value of that is pi/3. So that would have the same cosine. Now, going back over here to this other arc sine of 2pi/3, the reason I just reflected that is because these will have the same sign, the same y value. Well, between the fourth and the first quadrant, Negative pi over 3 and pi over 3 have the same x coordinate, so that is the value I'll use for this. Now, inverse tangent of pi over 8. Pi over 8 is definitely in the first quadrant, so this will just be equal to pi over 8. Tangent is restricted to the first and fourth quadrants, if you recall. Brought that up a few times so far. All right. Last part of number 6 is inverse tangent of 11 pi over 9. I need to think where that is, actually. So 11 pi over 9, okay, so 9 pi over 9 is pi. So it's 2 pi over 9 rotated past that, so that is in the, that appears to be in the third quadrant. All right, now, as I just said, this is actually 2 pi over 9 away from the axis. That will be useful. And the value of the tangent there is negative, right? Negative slope. So my reference angle will be in the first quadrant with an angle of 2 pi over 9 from the positive x-axis. So this is 2 pi over 9. That reference angle will be very useful. But again, it has the same tangent at that value, just like we talked with the x values, the y values, those have the same slope in that location. All right, for number 7, we have arc cosine of sine of negative 11 pi over 4. Now, I hope you've noticed just right there, those aren't the same function. Right? Arc cosine of cosine is a different story than arc cosine of sine. So for each of these, I'm going to actually just evaluate this from the inside out. So I'm going to find the sine of negative 11 pi over 4. So let's see, pi over 4, it's 45 degrees, so 90, that's 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi over 4, 11 pi over 4. So I believe this ends up on the negative y-axis. Now, unless I miscounted in there somewhere, honestly. So every 4 is back to pi. So this, I'm going in negative rotation. So I have 4, 8, 12. I don't know how I miscounted that actually, but that would end up actually right here in the third quadrant. The third quadrant. 4, 8, 11. Okay, yep, that works. All right, so that is an angle of, it's equivalent to a 5 pi over 4. 5 pi over 4 positive rotation or a negative 11 pi over 4, those are coterminal. So the sine of something like that, since it's a multiple pi over 4, in that way, it will be a negative root 2 over 2. So the sine of negative 11 pi over 4 is negative root 2 over 2. And we want to know the arc cosine of that. So what angle would that be that would have a cosine of that? A cosine of negative 2 over 2, well, that would actually be in the second quadrant. It's in the second quadrant because we're restricted to the first and the second. And that would be a 1, 2, 3 pi over 4. So 3 pi over 4. Okay. You have to think about where cosine and sine are negative, which quadrants those are positive and negative in. All right. The next part of this is cosine of inverse tangent of 5/12. Now, because this is a ratio, I'm going to have to actually tackle this question a little differently. So I'm going to actually draw a triangle, and it's a positive tangent, so that must be in the first or the third quadrants. I'm going to draw a triangle with an angle of theta labeled, and I'm going to use 5 for my opposite and 12 for my hypotenuse. And if we apply the Pythagorean theorem to that, it would be 144 minus 25. Oh, whoops, actually I said opposite hypotenuse. That is actually opposite and the adjacent, so that would be a x coordinate of 12, a y coordinate of 5. Now this will actually work. So 144 plus 25 is 169. The square root of that is 13. So the hypotenuse is 13. Now this is particularly useful because I use this inverse tangent of 5/12 to draw the triangle, but now to find the cosine of that angle, I just need the ratio of adjacent over hypotenuse. The adjacent is 12, hypotenuse is 13, so the answer to this is 12/13. Right, now I'm going to do a very similar thing with this for the next part, which is cosine of inverse sine of 7/9. I'm going to use this inverse sine of 7/9 to draw a triangle. I'm going to label the angle theta, make it a right triangle. Because it's the inverse sine, this is the opposite is 7, and the hypotenuse is 9. Use our Pythagorean theorem once again. That'd be 81 minus 49, which is 32. So the adjacent side is the square root of 32, all right, which is 4 square root of 2. 4 times the square root of 2. Now I can use this triangle to find the cosine of this angle that I've created. I don't know what the value of it is, but I do have an angle located using these side values. So now I can find the cosine of that. That would be the adjacent over hypotenuse. That would be 4 radical 2 over 9. The last two parts of number 7 are important, okay? Now, in just a moment, we're going to do this with something more generic because that's how it usually shows up in Calculus 2. So I want you to see what this little aspect might look like in this area. So try it number 8 is evaluate the following. Cosine of arc sine of x over 3 for x between negative 3 and 3 inclusive. So I'm going to take this inverse sine of x over 3, draw a triangle, angle theta labeled. I'm going to label as a right triangle. Now, arc sine tells us that this ratio is opposite over hypotenuse. So opposite side in this triangle is x. The hypotenuse will be 3. And if we use what we know about the Pythagorean identity, that this third side, the adjacent side, will be the square root of 3 squared, which is 9, minus opposite side, which is x, so x squared. So adjacent side is the square root of quantity 9 minus x squared end radical. Now that we want to know the cosine of this angle here, we will have the adjacent over the hypotenuse. So this will be the ratio square root of 9 minus x squared end radical, all divided by 3. Okay. For our last question, we have the sine of inverse tangent of 4x. So there is no denominator here, so we're thinking about ratios. There's no denominator, and this is, by the way, between negative 1/4 and 1/4 inclusive. But I'm going to write 4x as actually 4x over 1, so that on my triangle, my right triangle with my angle theta labeled, the opposite side is 4x, and the adjacent side is 1. That means that the hypotenuse, using the Pythagorean theorem, is the square root of 1 plus 16x squared. Because we would square 4x, that would be 16x squared. 1 squared is 1. We're summing these because we're finding the hypotenuse. So now that we come up with this triangle, we can now say that the sine of that given angle is opposite over hypotenuse, which would be a numerator of 4x and a denominator of square root of 1 plus 16x squared. Close that square root. Now, I can't say this enough. This problem right here is actually something in calculus too. A lot of students, they may be able to do a lot of the hard work, but then they get to the very end of their question and they don't remember how to draw one of these, how to actually make a triangle. To take an expression like cosine of arc sine of x over 3 and turn that into something meaningful in terms of x. So that being said, that is the end of this section. I hope that you soaked in a whole lot of this, and if you didn't, go back and rewind it. Go back to the other videos. And we'll, of course, answer some more of these questions, hopefully in class next week. Thanks for watching.